All right, here we go. Fourth grade. We've got this is lesson 9. This is subtracting fractions, and basically what you have in fourth grade is the denominators are going to be the same. So we shouldn't have to find a common denominator. So the denominators will be the same. We will use a common denominator to compare. And then in fifth grade, when you add or subtract, you'll have to find a common denominator. So I don't think we're going to see where we have to find a common denominator, but they'll be the same. One of the things we're going to look at is they want you to be able to, the state wants you to understand number lines and fractions that are fractions greater than, let's say, benchmark fractions. Okay, and hopefully you remember a little bit of that. Benchmark fractions are things like 1/2, 1/4, 3/4, common fractions that we know, and 1 whole. Okay, so we'll start with that. This one says Allie bought a carton of eggs. He used 3/12, so used 3/12 of the eggs to cook breakfast, and then used another 2/12 to make dessert for dinner. What fraction of the carton is left? So in this case, if you can draw, if you take the time to draw something, it's always going to save you time. So here we have a carton of eggs. Okay, so that should be common. You should know. You can just draw a carton of eggs. There are going to be 12 eggs in a dozen. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there's one. You just drawing that. Now you know he used 3/12. Okay, so we'll just kind of go through here and say, well, first of all, what does the 12 mean? How many to make a whole? How many to make a whole here? How many eggs? That will always tells you your denominator. So 12 parts to make a whole. Okay, and then in this case there's all 12 there. There's all 12 there, but the denominator, that's what's going on. He used 3/12. So if you say you use 3/12, that means three of the parts were for, I'll put a B here, for breakfast. So I could put like a B, there was used for breakfast, that was used for breakfast. 3 of the parts. Does that make sense? That's what this numerator means. It's telling you how many parts you used or shaded or whatever. Okay, and then we also have 2/12 to make dessert. So 2/12 was used to make dessert. So we could put a D for dessert. A D and a D. 2 of the parts. What fraction of the carton is left? Well, the fraction that's left is all this part right here. So you have how many eggs left. Now notice it doesn't say how many eggs are left. That's a different question. So if it asked you how many eggs are left, you'd be 1, 2, 3, 4, 5, 6, 7. It'd be 7 eggs left. And if that was the question, that'd be fine. But it's asking you this. What fraction of the carton? In other words, what part of the whole? So what's actually left is 1, 2, 3, 4. There are 7/12 left. Okay, 7/12 left. So we could do it that way. All right, so there's one way to do it, and that's why with math it's really awesome, because there's always multiple ways to do things. So now let's do it on a number line. Okay, so let's come down here. And basically what we're doing is we're saying that he starts with a whole here of 12/12. That's what we had up here, right? We had 12/12. And then it says he used, and so using is subtracting 3/12. So you go back 3. 1, 2, 3. So there's minus 3/12. And then he used another 2/12 to make a dessert for dinner. So you go back 1, 2. There's the minus the 2/12. And then we end up with 7/12. So just another way to do that on a number line. So what does an equation look like for this? So we can also write this just with numbers. No drawing, no anything. Equation just says, well, we'll start with the whole. We had 12/12. Or 1 whole carton. Okay, but we know we're subtracting fractions, so if we use a fraction, it's much easier. Minus 3/12. And then we could actually say minus 2/12 again, but you won't see that too much in fourth grade. But next year you would. I could actually tack on and say minus 2/12. But it just looks weird. So it's easier just to say, okay, let's just start with this part here. Oops. Okay, so after breakfast, he's got 9/12 left. And then from 9/12 we can subtract for what he used to cook the dessert for dinner. Okay? And it's always a good idea to put a box around that. Okay, let's go and take a look. Let's go to the next. Keisha is going to her friend's house 8/10 miles from her home. Her mother drives her part way, then she walks the last mile. Okay? So again, you could just draw a picture here. You can say Keisha is going to her friend's house from home. So you could just put a box here, and this could be Keisha. This could be Keisha's home. And she's going to her friends. Could even just say K and then F for friends, okay? So she's going to get in the car, and her mom is going to drive her. She's going to her friend's house 8/10 mile from home. So we know that, let's put that on here. So her house is 8/10 of a mile from the home. So that means this is 8/10. That means that's the whole. That's how far she's going to go. She's going to go 8/10 of a mile. Okay? And then her mother drives her part way, and she walks the last 3/10. So her mother drives her part way. So maybe her mother drives to here. Could even do it just like this. There the mom drives and then stops right there. You could say mom. And then on the other part here, this is where she's walking. Let me do a gray. So she's walking. Then she walks. Okay? Now we know how much she walks. We know this part is 3/10. And so in math, you always have wholes and parts. We know the whole thing here. So this whole thing is 8/10, right? This part here is 3/10 that she walks. So then you could easily say, oh, okay, well, I get it. I can take 8/10. Several ways you could do it. I could say 8/10 subtract 3/10 equals 5/10. Or I could say, well, one part is 3/10, right? Plus something equals the whole of 8/10. And you could also do it that way. Let me pause this here really fast. Okay, so the other thing is, let's look at it on a number line. It's kind of like the drawing we just did, so we'll do it. So our whole here is tenths. Okay, starting at 0 and going to 1. So our denominator is 10, so we have to divide the whole into 10 parts. So we can do that by going in half, and now we know we have to have 5 parts here. So each time I draw a line, that will be 1 part. So I'll need to draw just 4 lines. Watch. 1, 2, 3, 2, 3, 4. So if I draw 4 lines, then I have 1, 2, 3, 4, 5 parts. Okay, this would be 5/10 right here. 5/10. Same thing over here. 1, 2, 3, 4. That gives me 5 parts on this side. 1, 2, 3, 4, 5. Now I probably should have done a little better job of making them even, because that is important. You're dividing something into 10 equal parts, but it's hard for me to write on this screen, so can't really do that. All right, so we've got 5/10, and we can go ahead and say she's going to her friend's house. We'll go ahead and note that on here. Her friend's house is 8/10, so if I count this over, I'd be 1, 2, 3, 4, 5, 6, 7. So right here would be 8/10. Okay? And if she walks part way, she says she walks the last 3/10 of a mile. So I could show that on here, that this is the part where she walks. I could say 1, 2, 3. So I could put walks 3/10. Again, just showing the same thing on a number line. Okay? So then her mom must have driven her this part here. Her mom drove her up to here, which is 1, 2, 3, 4, 5. And it just happens that I happen to have that labeled because that was halfway. Mom took her 5/10. Just another way to do it. Use arrows to show the problem on the number line you drew in problem 1. Okay, so you could just put some arrows on here showing you went backwards. How far did Keisha's mother drive her? 5/10. Write an equation for this problem that includes your answer. So an equation, you could do several ways. Again, you could say 3/10 plus 5/10 equals 8/10. Or you could have said, all right, I'm going to start with the whole, and I'm going to subtract how far I know she walked, and that's going to equal 5/10. Okay, this way is probably going to be more common, okay, because it's actually, in order to find the answer over here, that's actually what you're counting up or kind of subtracting. So, all right, let's go take a look. The next one. Whoops, sorry about that. Okay, let's look at a problem. It says Anna made a quilt by sewing. Let me just double check. Yeah. Anna made a quilt by sewing together green, white, and yellow fabric. Okay, when she was done, 2/6 of the quilt was green and 3/6 was yellow. So the rest was white. What fraction of the quilt was white? Notice they're asking us for this time. It's not how many inches or anything like that, but the fraction. So that means we have to have a numerator and a denominator. Well, let's just sketch it. So she's got a green, white, and yellow fabric. So I can actually do that here. I can say, here's a quilt, and I got some green, and I'll use black for my white, and some yellow, kind of gold, I guess. So I'll pretend like those are the different parts, right? All right. 2/6 of the quilt was green, so there's 2/6. 3/6 is yellow. And the question is, so how far is this part here? So again, with fractions, it's always going to be parts and wholes. Okay, so we know that 6 means it's 6 parts to make a whole. 6 parts to make a whole. And this numerator up here tells you the parts you're counting, or the parts you have, or the parts you want to find, okay? The parts you have, the parts you are interested in. So in this case, the whole quilt would use, so one whole uses 6 parts out of all 6 parts. That's what we're talking about. So just think about that for a little bit. So what fraction of the quilt is white? What fraction of the quilt is white? You can kind of look that through. You're going to say, well, 2/6 plus something plus 3/6 has to equal to the whole quilt. And I could write one whole here, or since I'm dealing with a fraction, I could write 6/6, because that is one whole. Remember, the bottom number means it takes 6 parts to make a whole, and I need all 6 parts. Okay, so that would kind of lead you to the conclusion. You'd be like, oh, 2/6 plus 3/6 is 5/6, so it looks like 1/6, 1/6, right? And all they're asking you to do really is just show your work here. So this would be enough. Okay, that would demonstrate understanding to me clearly. You could also say, oh, okay, 6/6 minus 2/6. You could do it one part at a time too. Equals 4/6. And then you could do, okay, now let's take away the 3/6. So you could use that. You could also write 1/6 and sort of draw an arrow to your number, okay? Draw an arrow. So it's 1/6. What fraction of the quilt was white? 1/6, this is important though, we need to go ahead and note this, was white. Notice it says show your work. So now if you were on a test, you've got tons of work here, tons of work, okay? All right, let's go to this next one here. What is 9/8 minus 8/8? Use a number line or an area model to show your thinking. So a number line we know. An area model really just means like They look like tape diagrams. That's kind of what they mean. Okay, 9/8 minus 8/8. So let's think about, well, what in the world does 9/8 mean? So again, and really I wish they would just say, if it was me, I guess they've given us this instruction, but if you could demonstrate it any way you can, there's a lot of ways you can show them your understanding. So let's look at 9/8. What does that 8 mean? Really important. 8 parts. And you really should write this down and really just over and over and over and over again. 8 parts to make a whole. That's what that means. You got to know what that number means. This means you have 9 parts. So if you think about that, if that's a pizza, right? If that's a pizza, we'll just make one. I'll make an area model, or what they want to call it. If I put this in 8 parts, divide it in half, I need 4 on this side, so I'll do 3 lines. On this side, so I'll do 3 lines. Okay? So I now have 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 out of 8 parts. This says I have 9 parts though, so what would I have to do? Well, I'm going to have to draw another hole. I don't know if I can draw over here. No, I can't. Okay, hold on, let me move me down a little bit. So I should do this where it looks the same, but what happened was I wasn't able to, in other words, these 2 pizzas should look the same. Here, let me just fix it here real quick. Okay, so I just redrew this because we're going to come back to, I have 8 out of 8. 8 parts out of 8. That makes a whole. But again, I've got 9 parts up here. 9 parts. So I'm going to, in order to get 9 parts, and it takes 8 to make a whole, by definition of that, right? I'm going to have to draw. I can't just write a part in here, because if I try to make one of these, if I try to like put another slice in this pizza, sure, that'd give me 9 slices. But my denominator would have to change, because then it would mean that I have 9 to make a whole. So I am just going to make another pizza, and I just drew this because they should be the same size. Now it's hard for me to draw, but you got the idea. Okay, cut it in half. This pizza, by the way, also has to have 8 parts. That's my denominator. So altogether, what I could do, this altogether, that's what 9/8 looks like. Does that make sense? 9/8 looks like more than one whole. Okay? Now they want us to use a number line, okay? Or an area model. Okay, so I had to adjust my recording because I noticed, I gotta erase this, when I made my number line, I just started thinking tenths. So I made a little mistake there, so I'm gonna come back here. So we're gonna talk about now, this solve the problem with the number line. And we have 2 holes over here, so we're going to have to, on our number line, we're going to have to make sure that we have 2 holes up here as well. So we have 0, 1 hole, 2 holes. Our denominator is 8 parts, so we're going to do, this will be our middle part, and then we have 1, 2, 3. That'll give us 4 parts on each side, 1, 2, 3. So let's look at that. We have, so I'll show you, because when you're numbering that number line, what you're actually doing is numbering these parts. So this is 1/8. That's the end of 1/8 right there. There's 2/8, 3/8, 4/8, 5/8. Oh, there's 4/8. Let me make sure I get that. 5/8, 6/8, 7/8, 8/8. Right? There's 8/8. So I also have to have 8 parts here. 3 lines gives me 4 parts on this side. 3 lines gives me 4 parts on that side. Total of 8 parts all the way across. And I want to come out here to 9/8. Okay? So 9/8, okay, minus 8/8. So we could just go backwards. 9/8, we just go from here, start. 1, 2, 3, 4, 5, 6, 7, 8. That's minus 8/8. That's what that looks like on a number line. So that might make, whoops, 9/8, sorry. That's what that looks like on a number line. I'm sorry, 8/8. We subtracted 8/8. And that might make more sense to you. So our solution, 9/8. Whoops. Get the black marker there. 9/8 minus 8/8 equals 1/8. And we did it both as a number line. And we use an area model, which is just another way of talking about pizza. Okay? All right. Speaking of pizza, here we go. Number 7. Shanice had 1 whole pizza. Okay? Smart girl. 1 whole pizza. After eating some of it, she had 4/6 of the pizza left. What fraction of the pizza did she eat? Well, first of all, always use a pan pizza, because if you try to do it with a circular pizza, it's really hard to make the slices even. So here's a pizza. There's our 1 whole, and we've got our denominator down here of 6. That tells us that there are 6 parts to make the whole. Again, look how easy that is. As soon as we know that, we know how to cut this pizza. We just cut it. Let's cut it in half, because there's 6 parts, and we'll put 3 on each side. So we're going to need 2 lines. Notice the 2 lines gives us 3 parts on that side, 3 parts on that side. After eating some of it, so she ate some, she had 4/6 of the pizza left. So here's how much was left. So 4/6, 1, 2, 3, 4. And that is 4/6 left. What fraction of the pizza did she eat? Well, we can definitely tell she had this 2 slices were eaten. So 2/6 eaten. There you go. Solution is 2/6. You can just put an arrow like that, because we did show our work. We can also do it with an equation or a number line. We could do a number line. So let's do a number line. There's 0 and there's 1. This whole has to be broken up into 6 parts. Remember, 2 lines, kind of like over here, those 2 lines, it makes my 3 parts on that side, 3 parts on this side. So 6 parts altogether, okay? 1, 2, 3, 4, 5, 6. So 1 whole is really 6/6. So she had some parts that she ate, and she had 4/6 of the pizza left. So we can just find 4/6 on here. There's 1/6, 2, 3, this would be 4/6. So this shows how much of the pizza was left. She had 4/6 left. So obviously she had to have eaten 2/6. Okay, just like we did there. We can also do it with an equation. 6/6 minus 4/6 equals 2/6. And there you have it. So really, please make sure you take the time to look at all the different ways to do this, okay? And just this 4th grade is really important, because next year, then there's just a lot of work in fractions. You want to be very comfortable with what does that denominator mean, what does that numerator mean. Great, you did a great job. Look forward to seeing you on the next one. Bye-bye.